We describe this as hoppy bitterness in order to differentiate it from other forms of bitterness, or astringency contributed by things like roasted grains or by tannins extracted from barley husks during mashing and lautering. These things can amplify the perceived bitterness of beer above the bitterness contributed by hops. Isoalpha acids are the primary bitterness compounds contributed by hops during wort boiling. The isoalpha acids present in hops require a change in structure called isomerization in order to be soluble in wort. This is facilitated by wort boiling. Different varieties of hops will have different levels of alpha acids that also have small chemical differences that affect their level of solubility in wort and beer. There are also forms of perceived bitterness in beer that are contributed by dark roasted grains, polyphenols, tannins, and hop compounds other than isoalpha acids. These compounds and their individual types of bitterness combine to form the overall bitter profile of finished beer. The addition of accurately measured hops early in the boil contribute to the dominant bitter additions in beer. A supplier's certificate of analysis for hop acid concentration is important to obtain, and the brewer must calculate for loss of bitterness in hops due to storage over time. Use of dry hopping can contribute to overall bitterness, as bitter compounds like alpha acid, beta acid, and polyphenols from hop leafy matter can be extracted by water and ethanol in solution.